My name's Simon Phipps. I'm a specialist in open source governance and open standards, and I work with the Open Source Initiative, the AlmaLinux OS Foundation, and other organizations. And over the last 2 years, I've unexpectedly added European legislative engagement to my consulting practice. That's been a result of a big change that has happened in the world of technology and legislation. The world has changed dramatically for technology. Most software disclaims any responsibility for what it does to you. If you ever go and look at some open source software, at the end of the license in big block capital letters, there is a statement that basically says, "You're on your own, kid." It says it in more words than that, and it's more legally enforceable, but that's pretty much it.
It also said it was free.
That has really been the world that has governed software in one way or another for the last 40 years. All of our focus has been on physical goods, but that has gradually changed. The nature of consumer products has changed. They are now mostly software. Even the hard bits are software. Chips are software. Also, the way that software is made has changed. Software is no longer all made by your supplier, the manufacturer of the box. Most software is actually written by someone other than the supplier of the goods that delivered them to you. In fact, in most cases, 80% of the software is drawn from a collaborative development by people that the manufacturer has never and will never meet. Meanwhile, the world of regulation has moved on. Software and technology now impacts our lives dramatically and can have serious consequences for our lives. And it was inevitable that eventually regulation would catch up with software disclaimers. And someone eventually was going to say, actually, you can't say you're on your own, kid, anymore. You've got to accept liability for that software. Well, that day has come. At the end of last year, the European Commission passed 2 significant pieces of legislation. It passed a piece called the Cyber Resilience Act, which extends the responsibility for the security of software to any manufacturer placing software on the market in Europe, either embedded in goods or as software as is. And also the Product Liability Directive came out, extending liability for the consequences of software to every supplier, so that you, as a citizen of the European Union, are now entitled to compensation if software harms you. Also, the AI Act has come along and drawn the evolving world of AI into this net. Now, regulatory conformance in the European Union is conditioned on compliance with standards. And so our standards system is also drawn into this network of intrigue. But unfortunately, our standards system has never met open source software and wouldn't know it if it was bitten by a piece of open source software. And this is going to be a problem. This changing environment is going to be a rich ground for software heritage. And I believe software heritage will make the world a better place by making the world of regulation a better world of regulation. On this panel, we want to ask what the future holds in cybersecurity and regulation. And so on the panel today, I would like to introduce you to Dr. Carolina Lavatelli, who is the co-founder and CTO of the Internet of Trust. She has extensive experience in the design, setup, and operation of security evaluation schemes for hardware and software-based products, and is an active member of international and European standards organizations. She works closely with stakeholders in translating cyber regulations into actionable compliance. Next to her is Dr. Olivier Zendra. He is a researcher at Inria and works in Rennes in France. He's been working on software engineering, compilation and program optimization and cybersecurity. He's a member of the HiPEAC Vision editorial board and co-author of the vision statement for it. He's in charge of cybersecurity and privacy aspects within it, and he is an expert on supply chain security. Mike Milinkovitch, next to me, has been the executive director of the Eclipse Foundation for over 20 years. My goodness, is it that long? Nothing that he did before that, and you have to trust me here, he did a lot, has been nearly as interesting or challenging as creating and running the Eclipse Foundation. He's a keen interest in all things related to the success and sustainability of the open source community. So my first question to the panel, and if you could answer as soon as you're ready, regulation has finally caught up with software. And it looks like the regulators are surprised to discover that software is made of open source. What do you think is the most important consequence of this wave of regulation that's come upon us? The CRA, the AI Act, the PLD, the AI Liability Directive, and more.
Good afternoon. Yeah, it works. Well, as Simon said, I'm coming from the hardware and software and embedded systems, and I think that open source and software in general will bring a lot to this ecosystem, to the cybersecurity ecosystem, mainly based on the software development life cycle processes, which will be enforced and assessed through this Cyber Resilience Act regulation. On the other hand, the kind of the hardware-based product will bring knowledge and a lot of experience and conformity assessment based on certification. Certification in now, you know, the CRA is ensuring a kind of interplay between several regulations and directives, like the NIS2 for the information system, and like the Cybersecurity Act also for the European certification schemes. So I think both hardware and software have a lot of things to say and to bring to each other, and I'm optimistic.
I think we're in for a period of unprecedented change, and happily, I'm not talking about AI. I'm probably the only person who's going to say big change and not say AI. So in addition to all the wonderful things that are happening in the world of AI, what we're going to have here is irresistible force hits immovable object. The irresistible force is the fact that we have regulations, and they are going to have to be reflected in how things happen. Otherwise, you're not going to be able to sell products in the European Union, which is going to be a big problem for anybody who's trying to make a commercial product on the planet. The immovable object is, as Simon alluded to, the current set of standard setting processes, and to a certain degree, to a large degree, the standards that we currently have. The problem, as I see it, or one of the many problems as I see it, is that none of the cybersecurity standards that exist today, and this is also true of functional safety standards, but let's stick on security, none of the cybersecurity standards that exist today reflect how software is actually developed. They are based on a fantasy that has not been true for over a decade, and how fast can we change these standards in order to reflect the reality that most of the software that you get in a product is built someplace else. All the existing standards that I'm aware of, and happily be educated otherwise, but NIST SSDF, common criteria, anything that I've ever read always assumes that the software is being developed by a single organization in a proprietary manner, where you have complete control over the software processes, right down to locking down the developers' workstations, and none of this has been true for a very long time. So it's going to be really interesting to see how fast we can evolve these standards to reflect the reality that has to be met.
So my take on Simon's question is that indeed we are living a historical moment, because we are going from a period where basically you could, as has been said, provide software without caring much about the consequences, to an era in which software providers are liable. This is a major shift, and this is a complete change of mindset from I don't care to I'm liable. So I'm not a legal person, I'm a computer scientist working on cybersecurity, and for me this is good news, because this means that you cannot provide software that has blatant defects without having trouble. And that's very important to move people. Usually, software was developed, well, software is developed for its functionality, for what it does. Banking software, I don't know, application, to purchase things, accounting, whatever. That's the functionality. That's what you sell to your customers. But you don't sell cybersecurity because you don't see it. Cybersecurity, when it works well, it means that nothing happens to you. So seeing nothing, it's not obvious. You see when you are hacked. You see when you have problems. You see when your information system doesn't work anymore, when your information is leaked. But you don't see when everything works. So cybersecurity was not seen and was not considered as an asset, but as a cost center. So it was not very motivating for software developers to do. Now there is liability with the CRA and the NIST directive, etc. And this means that if you don't do your job properly, you're going to provide software which has flaws, and these flaws are going to backfire on you because you're liable. This means that cybersecurity suddenly becomes something interesting for you, at least not to waste a huge amount of money. And you are aware of it because the regulation made this completely explicit. So that's a complete mind shift, basically. As a computer scientist, I like this, because working on cybersecurity, it means that the work that I do and my colleagues do is going to be even more valuable and even more considered and even more used to fulfill those needs of higher standards for cybersecurity and certification and standardization. Yet at the same time, it means that we have the necessity to provide, we have the mission to provide better tools. Tools to assess the vulnerabilities, tools to control the vulnerabilities, tools and methods to fix the vulnerabilities, propagate them, ensure they are not reborn after 10 years, etc., etc. So, as per the open source, I think open source is very important to have access to the source, that's in the name. This means that transparency is provided, which is one of the pillars of cybersecurity, not the only one. And initiatives like Software Heritage help a lot because they provide a huge amount of code, which is accessible to anyone to do experiments and to improve their tools, and which hopefully is rather representative, being such a huge amount.
Thank you very much. So really my first question that comes out of all that is, Carolina, you've worked with conformity assessments and on the use of standards in regulation. How do you think we should approach conformity assessment in the context of the CRA? Because Mike has said it just doesn't fit. So what should we be doing instead?
Well, I will start with the CRA itself. I mean, the CRA is a piece of work defining conformity assessment in several ways. I mean, there are basically 4 methods described there, from self-assessment to third-party assessment up to certification by notified bodies. And this makes it flexible, and at the same time, the CRA puts some constraints which are based on the criticality of the products themselves. The less critical the products, the more flexible, meaning that developers and manufacturers and integrators and distributors, because it's not only manufacturers, can choose the conformity assessment mode. Still, in the CRA, there's one set of requirements, essential requirements for the product life cycle, and for the handling of vulnerabilities. So one set for all, meaning there is no even distinction between requirements for hardware and software. Still, the classes of product that are identified in the CRA call for that distinction because for instance, class 1 of important products, class 1 are mainly software products. And on the other hand, the critical products are mainly hardware. based, although I know that hardware-based products run software, and that so software is everywhere. But the assessment methods of the CRA will have to be interpreted and customized and tailored. And the Commission has published the draft standardization request, which is almost finished, and the standard organizations are currently working on that. And I know it will be difficult. There are provisions for specificities, not only allowed, but required to the software community and to the open source community. So I think that there is an opportunity to define these programs.
So Mike, I can see you're itching to comment there.
So first, I completely agree with everything Carolina just said. That is accurate description of what's in the CRA in terms of how it impacts the manufacturers. It's when you start to push out of the manufacturer and start thinking about this almost infinitely nested supply chain that Roberto had one slide on, and that it starts to get a little bit more complicated. Because as you know, many of the people in this room are members of the free and open source software community. We all know the sustainability issues that we've got. We all know how many projects there are out there that have 1 or 0 maintainers today. How really this wonderful house of cards we have built. And so the challenge is when the manufacturers come knocking and saying, you know, dear project, can I please have your attestation form that you follow this standard for your security vulnerability handling? The good news is that from a sustainability perspective, there is a huge class of economic consumers of open source that have just said, thanks for all the free stuff, suckers, and never given anything back, and now there's a forcing function where they actually have to pay attention. That is the good news. The bad news is there's greater than 0 probability that they're all going to start paying attention on the same day. Imagine a world where even the best run project with 50 maintainers and a great culture and so on, and which means they're important, which means they have a lot of people building products on top of them, get inundated. And anybody who's around running an open source foundation or a project in the Java world, when Log4j happened, this happened to you. It certainly happened to us at Eclipse. And when these companies, they don't have a culture of contributing back to open source. They have a culture of demanding things from their suppliers. And I've downloaded your software, damn it, so you're a supplier. Right? So when just a couple of weeks ago, DORA came into effect in Europe, and we started getting emails at the Eclipse Foundation saying, we demand that you fill out the following set of submissions attesting that you meet the DORA requirements. Because we downloaded your software for free, so that makes you a supplier. And so we had the whole we're not your supplier conversation. Right? Now, amplify that by 5 orders of magnitude. And so we have a lot of work to do to get prepared over the next couple of years to try to figure out what is reasonable, what can be done. And by the way, and I'll do a shameless plug here, sorry. So at the Eclipse Foundation, we have the Open Regulatory Compliance Working Group where we have the majority of the open source foundations in the world working with manufacturers to try to come out with process specifications that will help the open source community deal with this. And so please, if you're not already aware of it, look it up and engage. And that's honestly, I think, the best hope that we have as a community to deal with this.
So Olivier, how do you think the regulatory wave is going to affect the software supply chain?
So as was mentioned previously, about 80% of all the software in the world is open source software, even though sometimes many times it's used in commercial projects. These regulations call for tools basically to be able to enforce a number of properties that will be required in the certification processes that are still being figured out because it's not all implemented, it's being implemented currently. Carolina knows more about this than me. And to be able to cope with the sheer mass of software and to be able to analyze software, for example, to ensure that it is devoid from known vulnerabilities, which is one of the requirements of the CRA. To be able to do that, we will need automated tools that really scale massively. So this means that there is work to do there for the researchers to improve the tools. There is a market for tools that do that for commercial projects, but there is also a possibility to have those tools that are provided to open source projects as well. And so I foresee that these tools are going to be developing a lot. I see a lot of startups booming these days, working around the elements that are going to contribute to these, to the regulations implied by the CRA. For example, you have a number of startups starting to worry about the what we call the SBOM, the software bill of material, which is basically all the dependency of a software, because even though you write only a tiny program, most of the time if you do it in Python or Java, you are basically pulling out basically literally hundreds or thousands of libraries that you don't use it all, but you pull them for practical reasons. Automatically, you don't even realize it. These dependencies are not well known. It's not completely obvious to see, so you have to dig in. And it's time consuming, it's painful. Automated tools to do that are needed. Startups are starting to do that. And so I see that a number of tools will have to be integrated in the whole software supply chain, in the production chain, more precisely in the CI/CD, continuous integration, continuous developments. And this means that the assessments of the presence or absence of vulnerability, for example, is going to be one of those. There are others, but that's to illustrate this. So I see a reinforcement of the cybersecurity of the artifacts produced within the supply chain for the world, basically.
So we're coming to the end of our slot here. My last question for you, which I'd be very interested to hear. Given this set of changes that has happened, how can software heritage make things better here? What do you think software heritage can be or can do that will help the world be a better place after all of this change has struck us? And in as little time as you have, because we just had the 1 minute flag from the audience. Who would go out to you first? Mike.
Just be software heritage. Actually, the fact that you are giving us this asset that we can use with software IDs, giving us this very specific. This is the piece of the code that we're talking about. That is invaluable. We need to get that written into the standards. We need to use that. And I promise I wouldn't mention AI, but that's also pretty useful for people that are building AIs. But for these kinds of systems that need to be open, and one thing I will say is. The idea that the tools that would be used to implement the CRA conformance programs would be anything other than open source fills me with fear and loathing, because that automatically means they're effectively useless. Because if the community can't use them, that means only the manufacturers can use them, which means that all they're going to be doing is putting more pressure on the community without being able to even share the results of what the tool is saying. So we actually have a program funded by the European Union called Octet, where we're working on some open source tools for these kinds of things. And I think that's another contribution that I think is really important to the implementation of these regulations.
Thank you. Anyone else? Carolina.
Yeah, I fully support this vision, and I think that software heritage with this big and impressive database of lines of code should support the SBOM requirements that are already in place. I mean, SBOM requirements are a reality already. I mean, we haven't waited for CRA to require this, and also to bring more than that, more than identity and identification, to recognize patterns, to help identifying these known vulnerabilities in existing pieces of code, and even guessing the new, not yet discovered vulnerabilities, and what is important is actively exploited vulnerabilities, and this has been an improvement of the last CRA text, but still a lot of things to do.
Olivier?
So I would see two major axes of contributions thanks to software heritage there. One is, as I previously briefly mentioned, which is that software heritage, being a huge amount of open source code, is basically a huge data set to work with, and whether it is for machine learning or non-AI related topics. But it means that if you have tools that are able to perform properly on the huge amount of code that is in software heritage, tools that are there to, for example, detect vulnerabilities or other elements to progress towards certification for the CRA, then it means that you have a pretty solid tool because software heritage is just used. That's the first contribution. Let's say data set and playground to try your tools and to improve your tools so that they work properly. The second thing is that software heritage is not dead code. There's a lot of code in software heritage that is still used. This code may have also vulnerabilities. And so if you are able to sanitize all this code already, basically to sanitize the software world a bit more. So there's a kind of hitting two birds in one stone, I would say there, thanks to software heritage.
Thank you very much. Well, thank you to Olivier and to Carolina and to Mike for your input there. And it's now my great pleasure to invite my good friend, Professor Stefano Zaccaroli, to the stage, because he's got an answer to my question as well. And he's going to present that to us. But thank you to the panel.